Bismillahirrahmanirrahim. We start a new chapter in software engineering. After software requirements analysis, the next step in software development is software design concepts and principles. In previous chapter, we have collected user requirements, discussed different techniques, how to collect user requirements and how to evaluate them. Now once requirements have been evaluated and finalized, so next step is to draw the design on the basis of user requirements. This is the software design that we are going to build, and this is the first technical step for the development of a software. In this chapter, we'll be discussing different concepts and principles related to designing a software. Again, it is a task of software designer, basically software engineer, but who specializes in designing softwares. So let's proceed with the discussion agenda. What topics that we are going to discuss in this chapter? First, we need to develop an understanding with the term software design. So we'll be having an introduction on the topic. Next, we will discuss and draw connection between software design and software engineering. Then we'll be discussing the design process, the software design process, and how quality brings its role in software designing. So what is the role of software quality in software design? We'll be discussing that. Then we will discuss different types of software designs or different categories of software design. 4 different categories will be discussed in detail that include the data design, the architectural design of the software, the interface design of the software, and at the end, the component level design of software will be discussed. Then we will be discussing different design principles, what rules and regulations need to be kept in mind while drawing a design for developing design for the software. And at the end, we'll be discussing different concepts related to software designs that include the abstraction. What is abstraction? We'll be looking at it in detail when we'll be discussing this topic. Then refinement, modularity, software architecture, control hierarchy, structural partitioning, data structures, software procedures, and the information hiding. These are the different concepts within software designs that we'll be discussing in detail. So this is the outline for this chapter, the points that we are going to discuss in the coming lectures as well within this chapter. The first point that we are going to discuss today is the introduction. What actually is software design and why it is so important that it has been placed as one of the main phases for the software development. So this is the second phase of software development. First was the requirement analysis that we had already done in the previous chapter, and this is the second phase of software development, that is the software design, the main step within the software engineering. So let's proceed with the introduction and understand what software design actually means and what is its importance. The designer's goal mainly is to produce a model or representation of some entity that will later be built. So this is the role of any designer. Either it is the designer for the building, it is the designer for the clothing, or it is the designer for some road or bridge. Similarly, the role for the designer within software engineering is to produce some model or some representation of an entity that will soon going to be built. So here, in case of software engineering, the design is actually the meaningful representation of something that is going to be built. Similarly, the design as we generally develop in other domains. So how we can define a design? It is a meaningful representation or meaningful engineering representation of something that is going to be built. It can be traced to customer requirements and at the same time can be assessed for software quality or for the quality against a set of predefined criteria for good design. So when you develop a design for the software, that has to be then assessed against some predefined criteria for good quality. In the software engineering context, design mainly focuses on 4 major areas of concern. That means we are going to divide or disintegrate the designing phase in 4 sub-design phases. So first we have to develop the data designs, then we have to develop the architectural designs, then we design the interfaces for the software, and at the end we design the components, or we can also call it the component level design. Now, who develops software designs? Mainly the software engineer designs computer-based systems or computer-based solutions or the softwares. So software engineers design the computer-based systems, but the skills required at every level of software design work are generally quite very different. As I just said, we have to divide this phase in 4 different phases. So every level, work on every level requires different skills. At the data and architectural level, these are the 2 sub-design levels. So at these 2 levels, the data and architectural level designs focuses mainly on the patterns as they apply to the application that is going to be built. While at the interface level, the human ergonomics often dictates our design approach. So how we can communicate with the system, how the user will use the system, the interoperability of your software with other components of the system are the main focus at the interface level design. And at the end, the component level design, a programming approach mainly leads us to an effective data and procedural designs. So generally, a software engineer is responsible to design a software application which is going to be built. But since the design phase has been divided in 4 sub-design phases, so different level of skills are required for every sub-design phase. Now, what is the importance of this phase? Why software design is important and has been given a separate phase within software engineering? You wouldn't try to attempt to build a house without a blueprint. So without a blueprint, you would not like to build a house. You would risk confusion, errors, a floor plan that didn't make sense, windows and doors in the wrong places. So sort of a mess would be there if there would be a no blueprint. Similarly, computer software is considerably more complex than a house. So we need a blueprint, which is the design. So this is the importance of software designs. If you cannot build a house without its blueprint, so how can you think to build a software without having a proper blueprint, which is its design? Since softwares are more complicated than building a house, as it requires many different minor details which are generally hidden from the user who are going to then operate those softwares. So care is more required while developing a software, and that care is generally can be seen when we have done or we have followed the proper rules and principles for having a proper software design in place. A good software is the guarantee for a good design is actually the guarantee for a good software. The design begins with the requirements model, which we had already done in the previous lecture or previous chapter. We work to transform that requirements model into 4 levels of designs that I just said, the 4 sub-phases of design: the data structure, the system architecture, the interface design, and the component level design. During every design activity, we apply basic concepts and principles that we'll be discussing in this chapter in order to generate a high quality software at the end. So what is the working product? At the end of completing all the 4 sub-phases of design, the design specification is generally produced at the end of software design phase or software design activity. The specification is composed of the design models that describe 4 levels of designs or 4 sub-phases of design. That means the data designs, the architectural designs, interface design, and components. So these 4 designs are merged together at the end in the document, which is termed as the design specification. Every single component, such as data, architecture, interface, and components, are the work products of this design activity. At the end of every step of design, the 4 design types that we had just discussed. So at the end of every design activity, the work product is then reviewed. The output of that particular sub-phase of design is reviewed for the clarity, correctness, completeness, and consistency with the requirements and with one another. So 4 different sub-phases of design are there. 4 different designs are generated. So these designs are then reviewed for clarifying the requirements, for clearly understanding the requirements that has been placed in front by the customer. And those designs are also checked, reviewed with one another in order to observe the consistency with different types of designs that has been generated at the end of 4 sub-design phases. Now, the next point that we are going to discuss is the software design and its relationship with software engineering. How software design is related with the software engineering. Software design mainly sits at the technical edge of software engineering. So this is actually the technical phase. The requirement analysis was a non-technical phase that was merely dependent on paperwork. But this is the starting of the technical phase of software development. So this phase mainly sits at the technical edge of software engineering. That means technical phase starts from here. So software design sits at the technical kernel of software engineering and is applied regardless of the software process model that is being used. Beginning once software requirements have been analyzed and specified, as we had done in the previous chapter. So the design is the first of the 3 technical activities, which are design, code, and test. These 3 phases are termed as the technical activities or technical phases. So design is the first technical phase within software engineering. Every activity transforms information in a manner that ultimately results in validated computer software. So all the 3 technical phases would eventually lead to develop a computer software. Each of the elements of the analysis model that we discussed in the previous chapter provides information that is necessary to create the 4 design models required for a complete specification of design. The flow of information during software design is shown in this diagram here. You can see in this figure. Software requirements, which are represented by the data, functional and behavioral models that we had discussed in previous chapter in detail, feed the design task. So here you can see the entity relationship diagram, which is the output of the previous analysis phase, and during that phase we generated data models. During data models we develop entity relationship diagrams. Data flow diagrams are the output of the functional and informational models that we discussed in previous chapter. We developed 3 types of models in requirement analysis phase: data model, information model, that we also call as functional model, and the behavioral model, while the state transition diagrams are the output for the behavioral model. So the flow of information during software design as shown in this figure. Software requirements as shown by the data, functional and behavioral models feed this design task. Using one of a number of design methods which we will be discussing later on, the design task generates data design, 4 levels of designs, as we just said, the 4 subphases of design. So once these 3 elements are fed to the design phase, we result in data design, architectural designs, interface designs, and the component level designs. The data design, which is the first phase or first subphase of design, transforms the information domain model created during the analysis into the data structures that will be required to implement the software. The data objects and relationships defined in the entity relationship diagram and the detailed data content shown in the data dictionary mainly provide the basis for the data design activity. The second subphase of design is the architectural design. Architectural design defines the relationship between the major structural elements of the software, the design patterns that can be used to achieve the requirements that have been defined earlier for the system in the previous chapter, and the constraints that affect the way in which architectural design patterns can then be applied. Architectural design representation, which is also known as the framework of the computer system that is going to be built, can be derived from the system specification, the analysis model, and the interaction of subsystems defined within the requirements analysis model. This has been done in the previous chapter already. The third subphase of design is the interface design. So the interface design describes how the software will communicate with itself, with systems that interoperate with it, and with the humans who will use it. An interface implies the flow of information and a specific type of behavior. Therefore, data and control flow diagrams provide much of the information required for the interface design. So here you can see the connections between different diagrams and different level phases. Data flow diagrams mainly will result in the interface diagram. It will result in the architectural diagram as well. Similarly, data dictionary or ERD will result in the data designs. Here you can see ERD and data dictionary will result in the data designs. So the models that we had already developed in previous chapter, the analysis phase, will help in designing the design or the blueprint for the software. The last sub-design is the component level design, So the component level design transforms the structural elements of the software architecture into the procedural description of the software components. That means different software functions or different units, different modules of the software will be then designed in this subphase. During design, we make decisions that will ultimately affect the success of software construction and, as important, the ease with which software can be maintained. So now you can simply ask why software design is so important. So the importance of software design can be stated with a single word: quality. Design is the place where quality is fostered in software engineering. Design provides us with representations of software that can be easily assessed for quality. Design is the only way that can accurately translate customer requirements into a finished software product or a software system. Software design serves as the foundation for all the software engineering and software support steps that follow. Without a design, we risk building an unstable system, one that will fail when small changes are made, one that may be difficult to test, one whose quality cannot be assessed until late in the software process, when time is short and many dollars have already been spent on the development or construction of a software. The next point that we are going to discuss is what is a design process? How design process or why a design activity can be termed as a process. Now the next topic that we are going to discuss is what is the design process? So software design is mainly an iterative process through which requirements are translated into a blueprint for constructing the software. Initially, the blueprint depicts a holistic view of software. That is, the design is represented at a high level of abstraction, a level that can be directly traced to the specific system objective and more detailed data, functional, and behavioral requirements. As design iteration occurs, subsequent refinement leads to design representation at much lower level of abstraction. That means at high level of abstraction we would find just the major functions. But the more iteration goes on within the design activity, the more low level details of those functions are then highlighted. For example, the blueprint of the house generally shows you different rooms, windows, direction of windows, interconnection of different rooms. But the more iteration, more refinement of that blueprint will ultimately show the pipelines, where the pipeline for the water, the electricity are more moving within the building. So that will refine the blueprint. Similar iteration will refine the software designs. So as the design iteration occurs, the subsequent refinement leads to design representation at much lower level of abstraction. These can still be traced to requirements, but the connection is more subtle. Now, design and its impact on software quality. Throughout the design process, the quality of the evolving design is assessed with a series of formal technical reviews or some design walkthroughs. These are some mechanisms through which you can assess the software design for software quality, which you will be discussing in software project management. These are the software project management techniques basically. Here I am referring 3 golden rules for designing a software that will have good quality. So quality related principles for having a good software design are mentioned here. The first rules for quality design says the design must implement all the explicit and implicit requirements contained in the analysis model. All the implicit and explicit, that means implicit are those requirements if you remember when we were discussing the requirement analysis phase, and we had discussed, or when we were discussing the requirements elicitation process, there was a technique quality function deployment in which we had categorized the requirements of user. Three categories were being generated during that phase. That was normal requirements, expected requirements, and excited requirements. So implicit requirements are those requirements which have been understood by both the customer and the developer, and they are not told by the customers. So these requirements are known as the implicit requirements, while the explicit requirements are those requirements which are generally told by the customer. They are not understood to be present in the software, so they are generally told. So the expected requirements, normal requirements, are those requirements which are explicitly stated by the customer, and the expected requirements are those which are the implicit requirements. That means that must be present within the software as expected in every software. So those are the implicit or expected requirements, while explicit requirements are the normal requirements that are generally told by your customer. Generally tell them about those requirements. So the first design principle for quality states the design must implement all the explicit requirements contained within the analysis model, and it must accommodate all the implicit requirements desired by the customer. So both the implicit and explicit requirements must be depicted within your design. The second principle states the design must be readable and understandable. Your design should be easily readable and can be clearly understandable. That means this is the guide for those who generate the code. So for the developers, your design must be readable and understandable. And for those who test, who will later on test your software, and subsequently for those who are going to provide support or maintenance for your software. So your design must be readable and understandable for the people who will work later on your software. The third principle states the design should provide a complete picture of the software. Your design should be providing a complete picture of what is going to be built. That means the software, addressing the data, functional and behavioral domains from an implementation perspective. So all the three models, data model, functional model and behavioral model, must be addressed in the design from the perspective of the developer. Each of these three principles that we just discussed is actually a goal for the design process. Now, how software design evolved? Evolution of software design. The evolution of software design is a continuing process that has spanned the past 4 decades. Early design work focuses on the criteria for developing of modular programs. So previously, when software design was evolved, so the more focus one was on designing modular programs. That means the procedural aspects of design definition evolved in the philosophy, which we also called as the structured programming. So the program or the design was generally developed in methods for refining the software structures in more of a top-down manner. The main function, then sub-functions, then sub-function instead of a hierarchy. Later on, or the later work then focused on the methods for translating data flow or data structures within your software designs. Now the current approaches proposes an object-oriented design approach. Current research within software design mainly focuses on generating object-oriented design architectures and the design patterns that can be used to implement software architectures. In today, the most emphasis is given on software design is on the software architectures, how different design patterns can be used to generate modular or iterative designs. So this is how software design activity evolved in different phases. Initially, modular designs were used to be developed, and then the focus was given on translating data flow and data structures and integrating them in your design, and later on data design or design approaches mainly focus the object-oriented design mechanisms. But currently architectures are given more importance. Software architectures and different architecture patterns and styles are given importance, which we'll be discussing in coming lectures. That is all for now. We'll continue our discussion within this chapter in the coming lectures as well. In today's discussion, we started a new chapter and a new software engineering phase, which is the software designing phase. What all we discussed today is an introduction with the term software design. It is actually the blueprint for developing a software. Software design phase is generally divided in 4 different phases in which 4 different types of designs are developed. That is, first data design is developed, and then architecture design is developed, interface design is developed next, and at the end component level design is developed. Software engineer specializes in software designing, is responsible to develop the software design. But since every subphase of design requires different sort of skills or different level of skills, so many different people can also help software engineer to finalize the different level of designs. Software design is a good software design is the guarantee of a good software. So the design factor can be interpreted within your design. Different design principles or different objectives or different goals for design have been set for the quality. That shows 3 level or 3 different types of design objectives for good software quality has been discussed in today's discussion. The first goal states the design must implement the implicit and explicit requirements. The second objective of design is that your design must be readable and understandable for the later phases. And the third principle states the third design objective or the goal of design states that the design should provide a complete picture of the software. That means all the 3 models, data model, functional model, and behavioral model, must be represented within your design. Then we discussed the evolution, how software process or software design process evolved. Initially, there was more focus on procedural or structured designs in which the hierarchical divisioning of architectures or structure of or design of software were used to be developed. Later on, then data structures got importance that were then integrated into the software designs, and then object-oriented designs came into more focus. But the current trends are more emphasis is given on software architectures and different design patterns. That is all for now. We'll continue our discussion on more topics within this chapter. I thank you all.